Curiosity, the stunt double, presented by Science at NASA. With a pair of bug eyes swiveling on a stalk nearly 8 feet off the ground, the 6-wheeled 1,800-pound Mars rover Curiosity doesn't look much like a human being. Yet, right now, the Mini Cooper-sized rover is playing the role of stunt double for NASA astronauts and making an excellent impression. Curiosity is riding to Mars in the belly of a spacecraft, where an astronaut would be, explains Don Hassler of the Southwest Research Institute in Boulder, Colorado. This means the rover experiences deep space radiation storms in the same way that a real astronaut would. Indeed, on January 27, 2012, Curiosity's spacecraft was hit by the most intense solar radiation storm since 2005. The event began when sunspot AR-1402 produced an X2-class solar flare. On the Richter scale of solar flares, X-flares are the most powerful kind. The explosion accelerated a fuselage of protons and electrons to nearly light speed. The subatomic particles were guided by the sun's magnetic field almost directly toward Curiosity. When the particles hit the outer walls of the spacecraft, they shattered other atoms and molecules in their path, producing a secondary spray of radiation that Curiosity both absorbed and measured. Curiosity was in no danger, says Hassler. In fact, we intended all along for the rover to experience these storms en route to Mars. Unlike previous Mars rovers, Curiosity is equipped with a radiation assessment detector. The instrument, nicknamed RAD, counts cosmic rays, neutrons, protons, and other particles over a wide range of biologically interesting energies. RAD's prime mission is to investigate the radiation environment on the surface of Mars. But researchers have turned it on early so that it can also probe the radiation environment on the way to Mars as well. Curiosity's location inside the spacecraft is key to the experiment. We have a pretty good idea what the radiation environment is like on the outside, says Hassler, who is the principal investigator for RAD. Inside the spacecraft, however, is still a mystery. Even supercomputers have trouble calculating exactly what happens when high-energy cosmic rays and solar energetic particles hit the walls of a spacecraft. One particle hits another, fragments fly, the fragments themselves crash into other molecules, making more fragments. It's very complicated. Curiosity is giving us a chance to actually measure what happens. Even when the sun is quiet, Curiosity is bombarded by a slow drizzle of cosmic rays, high-energy particles accelerated by distant black holes and supernova explosions. In the aftermath of the January 27th X-flare, RAD detected a surge of particles several times more numerous than the usual cosmic ray counts. Hassler's team is still analyzing the data to understand what it is telling them about the response of the spacecraft to the storm. More X-flares will help by adding to the dataset. Hassler expects the sun to cooperate because the solar cycle is trending upward toward a maximum expected in early 2013. As of February 2012, we still have 6 months to go before we reach Mars, he says. That's plenty of time for more solar storms. A stunt double's work, it seems, is never done. For more news about bug-eyed robots and other things in space, visit science.nasa.gov.